So on Brightspace, I posted two code, and one is called LU example. So that is to complete the LU decomposition of a matrix A. So you input a matrix A, and then like basically like this code going through it goes row by row to construct this the LU matrix. Of course, I throw in something extra. For example, your matrix need to be a square matrix. If you give me a matrix that's not a square, I cannot do LU decomposition because it has to be a square in this case. And then, here I'm forming the first row of U and the first column of L. So those two lines are pretty much the first two lines like over there. So that is to give you the first row of U and the first column of L. After constructing that, then I can start to form L and U row by row. And here the row number is like this I. So I'm starting from the second row, go all the way to the nth row. And then, during this formation, let's see what I need to tell you. So pretty much I'm just like following the rule listed on the whiteboard. But one thing here is that you see in this code, we have a lot of summations, right? For example, I sum over k of this Lik times Ukj. So there's one easier way to write such a summation. Because for example, if you want to sum AK and BK over K, a thing you can do is that you can write this as an A vector inner product with B vector, such that A vector has all the elements of AK, B vector has all the elements of BK. So when you do this, so let's say if n A vector and B vector, they are all a column vector if they are n by 1, then what you can do is you can take this as A vector transpose times B vector. So A vector transpose is 1 by n, and B vector is n by 1. So you have a 1 by n matrix times an n by 1 matrix. What's the result? It's just a number. It's a 1 by 1 matrix, which is a number, and it's an inner product, and it's a sum. So I use this notation a lot. So this is like some too advanced stuff I don't want to talk about it, but somehow if you do matrix multiplication, the speed in MATLAB is 10 times faster than you write the sum by yourself. So I don't know if any of you know. So this kind of this is called a MATLAB, the software. Do you know what MATLAB stands for? Yes, the matrix lab, right? So it handles matrix very well. So when you do matrix multiplications, like MATLAB use some very optimized code that can access your memory in the most efficient way. So it can guarantee, like if you have two matrices times each other, it goes way faster than you do this by yourself and write down the summation. So here, a lot of those summations, so I did in such a inner product manner, so you have to figure it out. So after going through all the rows, then your LU decomposition is complete. You have the matrix L and the matrix U, and that's the two returned matrix. This is one example I posted. Another example I give you is that how to use the LU decomposition to solve a linear problem that is like A times X equals to B, and the A matrix is formed here, B vector is formed here. Show you. So basically, like A is a 3 by 3 matrix. That's actually one of the textbook examples. And the B is a vector that's 3 by 1. So then you should be able to solve AX equal to B as long as A is not singular. And in this case, I know matrix A, so I do an LU decomposition. I know the L matrix, I know the U matrix. And then, I go through the forward substitution to solve this L times Y equals to B. So this is what I talked about earlier. So I solve for the Y vector. I get to know all the values of Y, and then I solve U times X equal to Y by the backward substitution. So after doing that, you should be able to get your solution. So if I run this code, it takes no time, and then you can see this X is 1, 2, 3, which is like the answer of this problem. So I don't know what's gonna be the homework yet, but you're probably gonna do some similar problems. So make sure to read through those code and understand what every single line means in this case. Okay, and of course, like here, this LU example, like I mentioned before, last time we talked about, well, before the new year, we talked about if we try to solve such a system with, what should I say? If we try to solve such a system with Cramer's rule, then it's gonna take the time. The time it takes is longer than the life of universe, so it's not practical. So that in that example, our matrix, I think we did like 100 by 100 matrix, right? So in this case, let's see how fast things can go. So the example I posted, you're only dealing with a 3 by 3 matrix, but very easily I can expand this to 100 by 100. What I do is here, I want the matrix A to be a random matrix of 100 times 100. So run 100, so that means like, this is a MATLAB code, so that means we'll generate a 100 by 100 matrix such that each element is a random number uniformly sampled between 0 and 1, okay? And similarly, I want the B matrix, I want the B vector to be 100 by 1. So if you do that, if you run this, then you can see this A is a 100 by 100 matrix, and whose element is like just all random numbers, and the B is a 100 by 1, a column vector. Then we should be able to solve for X in this case. Let's see how much time it takes. Okay. So I'll run the code. So I'll press run, and it's done. It's this fast, it's already done, and I know that, so X is also 100 by 1, so we can solve all the value of X. This algorithm turns out is so much better than the Cramer's rule. So in fact, this is just my laptop. This thing is like 5 years old. I can do 1,000 by 1,000. Let's see how fast it goes. It's gonna take some time, but it shouldn't be that slow. I run this. Okay, well, this does take some time, and it's done. It's take like a second for the computer. 1,000 by 1,000 matrix inversion. So we still have a couple minutes. Like one quick thing I can tell you about is that, so sometimes this is what we're gonna do next week actually. Sometimes when you run a code, you want to know like how long does the code take, because then you can get an idea of where I can improve. In MATLAB, you can do such a thing. So MATLAB has two functions. One is called tick, the other is called talk. So tick tock. Okay. So when you do tick, MATLAB starts with time. Like it said, let's start here. Let's time how much time we have gone through. And when you want to end, you do talk. So basically, MATLAB will time like how long does it take to run for all the lines between tick and talk. Because in this code, what you're really concerned with is that like how long does it take to compute your result. You don't care about how long does it take to form all those random matrices. So I start the tick here and the talk here. So if I do this, this is 100 by 100 matrix. You can see the time it takes is 0.04 seconds. And if I make the matrix twice of its size, so times 2, you can see it'll take more time. Now it takes 0.118 seconds. If I make it 4 times its size, it takes 0.435 seconds. So in this case, as you can see, well, this actually is this is kind of a bad example because is it bad? Oh, it's not. It's kind of a bad example. So pretty much, like every time I make my n, I double my n. The amount of time it takes becomes 4 times of the previous step. What does this mean? So the amount of time should be proportional to the number of operations you did. So in this case, what this is telling you is that if you're dealing with matrix n, and then the amount of operation is proportional to n squared, because n becomes doubles and n squared becomes 4 times itself. This is kind of a bad example because it's supposed to be n cubed. So this is only n squared. That means MATLAB is doing something smart for you. So it's going faster than it's supposed to be. Anyway, so that's it for today. But try all this code and try this whole TikTok thing, and you can use that to time your code. All right, so I'll see you on Monday.